Welcome to my channel. In this video we will discuss about resistors in series and parallel. Resistors in series. In many electrical circuits, resistors are connected in series or parallel. For a series connection, the current flowing through each resistor is equal because there is only one path for the current to follow. The voltage drop is proportional to the resistance of each individual resistor. The diagram represents the series combination of resistors. Means resistors are connected in series by connecting the first resistor endpoint to second resistor starting point. The equivalent resistance of several resistors in series is given by equivalent resistor is equal to the algebraic sum of resistors. The voltage across each resistor is calculated with Ohm's law. That is V equal to IR. Example. Consider the circuit shown in the picture below. Two resistors R1 and R2 connected in series are subject to a constant current I of 5A. As shown in diagram. How can we calculate the voltage drop for each resistor, and how can we determine the equivalent resistance value for the two resistors? The current through each resistor is equal. Knowing this and using Ohm's law, we can find the voltage drop for R1 and R2. Voltage drop for R1 is equal to I multiplied by R1, that equal to 10 volts. Voltage drop for R2 is equal to I multiplied by R2, that equals to 15 volts. Equivalent voltage equal to sum of voltage drops for R1 and R2. That equals to 25 volts. The equivalent resistance is equal to the sum of R1 and R2, that equals to 3 ohms. Equivalent voltage is equal to 25 volts. Resistors in parallel. Resistors are often connected in series or parallel to create more complex networks. An example of 3 resistors in parallel is shown in the following figure. Resistors are connected in parallel. The voltage across resistors in parallel is the same for each resistor. The current running through each branch of the circuit, however, is proportional to the resistance of each individual resistor. The equivalent resistance of several resistors in parallel is given by inverse of equivalent resistance is equal to inverse sum of all resistances. And the current through each resistor is given by I equals V divided by R equivalent. For example, a circuit designer needs to install a resistor with 9 ohms and can choose from the E12 series of preferred values 10, 12, 15, 18, 22, 27, 33, 39, 47, 56, 68, 82. The value of 9 ohms is, unfortunately, not available in this series. He decides to connect two standard values in parallel to create an equivalent resistance of 9 ohms. The equivalent resistance value for two resistors in parallel is calculated using the following steps. From the required formula, that is equivalent resistance is equal to inverse sum of two resistances. By the cross multiplication we want equivalent resistance, then reciprocal the equation, then we get required equation. The above equation shows that if R1 is equal to R2, equivalent resistance is half the value of one of the two resistors. For an equivalent resistance of 9 ohms, R1 and R2 should therefore have a value of 2 multiplied by 9 equals 18 ohms. As a solution, the designer connects two resistors of 18 ohms in parallel, as shown in the figure below. Resistors in series and parallel. A more complex resistor network can be solved by systematically grouping resistors. In the figure below, 3 resistors are connected. Resistors R2 and R3 are connected in series. They are in parallel with resistor R1. To solve the network, the resistors are separated into two groups. Group 1 consists of only R1. Group 2 consists of R2 and R3. The equivalent resistance of group 2 is easily calculated by the sum of R2 and R3. This leads to the simplified circuit with two resistors in parallel. The equivalent resistance value of this circuit is easily calculated as follows. By using simple mathematical calculations on further simplification we get equation to equivalent resistance. Thanks for watching. Please subscribe and follow for more information. Take a second and comment me how I am doing. This topic notes is available in description. Please check the description.